Hello again everyone, welcome back to ptet.chemistry channel. So in this tutorial video, I'll continue this topical MCQ on atomic structure. So this is question 26 of a 5-question series from 26 to 30. This start off by talking about radioactive isotope of thallium. So the term radioactive itself means unstable nuclei or unstable nucleus. Okay. So use this isotope to assess damage in your heart muscles after a heart attack. What about this particular isotope is correct? Well, we know the proton number is the atomic number. That is the number 81 there. Because we are talking about an atom, so the number of electron equal to the number of proton. Because this is an atom, not an ion. The number on top there is what you call the nucleon number. So the nucleon number is not 120, it's actually 201. So the nucleon number is the number of neutrons and protons in the nucleus. So by taking away the number of protons, I can get the number of neutrons. So I can get 120 neutrons, not 120 nucleon. Okay, so the number of electrons is 81. That is actually correct because we have an atom is equal to the number of protons. Okay, the number of neutrons is not 201, it's 120 as I mentioned, and this is element 82. You see there are different proton number, therefore these are different element. When you are different element, you cannot be an isotope because isotopes are atoms of the same element. So by definition, that is already incorrect. Moving on to the next question. So you have 3 successive elements, have their first ionization energy, having that pattern. So what could be the first element in this sequence? So you know across a period, well in fact, if I just draw first ionization energy, so we know there's a slight drop between group 2 and group 13, and then we know there's a slight drop between 15 and 16, and then the biggest value will be group 18, noble gas, and then it goes all the way to group 1 again, where it is lower than that because you're in a new shell, so it's much easier to remove the valence electron from the new shell, which is further away and more shielded. Of course, these are the common things they like to ask you in an essay-based question. In a paper 2 or paper 4 setting. So explaining this drop due to filling in the P subshell versus the S subshell. Explaining this drop due to the paired electron repelling more than the unpaired electrons in the P3 configuration versus the P4 configuration. So we have a drop between there and there. So this could be 2 to 13. So I'm saying this could be 2 to 13, or meaning this is 1, or it could be this could be 15 to 16, which means that must be 14, or it could be this is 1 and then this is 18 and then this is 17 because they are consecutive elements, right? Okay, so we gotta think about, are they group 1, group 14 or group 17 based on it dropping down. Okay, dropping down like that, dropping down like that, and dropping down like that. What could be the first element? So this is group 14, this is the group number, this is group 15, this is group 17, this is group 1. So we can cross out 7, the first element, right? The first element, we're just looking at this. We can cross out 15. Then we're left with 1, 14 and 17. Then you need to think, okay, we need to think which one is possible. When you have this drop are usually very small, okay? These drop are very small, these drop are small, okay? So when I think about that thing and that thing, those are small drops, okay? They are small drops. Typically they are smaller than the previous one, but they are not smaller than the other previous one. Okay, so usually like if they are 2 and 13, there will be somewhere small drop, but it wouldn't be lesser than the previous one. Okay, same deal with that. So essentially what we're looking at here is the filling in of a new shell. So I have to go with this being filling in the new shell. So it is that. So we're looking at the first element being group 17. That is the most sensible and most rational based on knowing that these are very small drops. Question 28 is about working out the relative atomic masses. So you're given the relative abundance. These are not percentage, they are just relative abundance. And this one has a relative abundance of 4. This one has a relative abundance of 1. So relative atomic mass is going to be what mass do you have, which is 10, multiplied by your relative abundance, which is 1. Add that up. This is the mass number, 11, multiplied by the relative abundance, which is 4, divided by the sum of your relative abundance, which is 1 plus 4. So use a bracket for the top bit and the bottom bit because you don't want to be making mistakes with your calculation. 10 plus 11 times 4 is 54. At the bottom is 5. So 54 divided by 5, I get 10.8. And how do you know your answer is correct? Is that, well, you have got a value 10 and 11. You're averaging something in between. So your value will be something in between, which is what this is. It cannot be 11 because you have a value at around 10 point something. You have a lot more of the 11 than the 10. So it will be closer to the 11. And this is closer to the 11 than closer to 10. So 10.8 is perfectly legit. 10.5 is unlikely because that would mean you have 50% of each because there's exactly in between. 10.2 would mean you have a lot more of the 10 than the 11, and there is the opposite here. You have a lot more of 11 than the 10. In this question 29, so you have electronic structures of calcium, krypton, phosphorus, and an element X. So which one is element X? I can work out calcium, I can work out krypton, I can work out phosphorus. By working these three out, then the other one must be X. Alright? So let's have a look at this. This is a period 3. This is group 15 because there are 5 outer shell electrons, 2 plus 3. Okay, so period 3, group 15, that is phosphorus. So that one is not what we want because X is not phosphorus, X is not krypton, X is not calcium. Alright? This is period 4 because you can see the 4s2 and there's 2 electrons in the s orbital. So this is group 2. That is going to be calcium. Again, that's not what you want. Krypton, it should be nice and easy. It's a noble gas. Okay, so it's got a completely filled outer shell configuration. I hope you can see that this is completely filled. Okay, that is your krypton, and that is period 4. So find your period 4. At the very end, you should see krypton there. So that is your configuration, electronic configuration for krypton. I already identified for the 3 elements there, which mean element X must be C. Alright? I probably shouldn't put a cross. That would imply that it's wrong. Okay? This is the last question of this 5-question series. So John Dalton has this atomic theory. It has 4 predictions about atoms. Which of his prediction is still considered to be correct? Okay, it's still considered to be correct. Well, it said atoms are very small in size, but proton, electrons, neutron, even smaller because these are the components that make up an atom. Alright, no atom can be split into smaller parts. Well, you have radioactivity. Radioactivity is a result of unstable nucleus. When you have unstable nucleus, you can split into different elements, which have smaller 2 different nucleus with different number of protons, so different elements. Because you have unstable nucleus, you want to split into smaller nucleus. All the atoms of a particular element have the same mass. Well, you can think about isotopes. Okay, you can think about isotopes, and you can think about 35 chlorine, 37 chlorine. Your case study, 3:1 ratio. These are atoms of chlorine. They do not have the same mass. Alright, so C is definitely wrong. B is definitely wrong. All the atoms of one element all the atoms of one element are different in mass from all the atoms of other elements. You know, you have carbon 12, you also have carbon 14. We use carbon 14 for carbon dating, you know, like when they say half-life, they use it to monitor half-life of mummies, for example, mummies, dinosaurs, fossils, you know, to determine how old they are. So they use carbon dating using this radioactive isotope. And of course, it says that atoms of one element are different in mass from the atom of other element. You can have nitrogen 14. This is nitrogen 14 isotope. Alright, so I'm talking about isotope. Guess what? They have the same mass. They are atoms of different element. So not all the atoms are different in mass. So D is wrong. By contradiction, it seems that I have to go back to A, because A does not say that atoms are smaller than proton, electron, neutron. It just simply says atoms are very small in size. And by contradiction, I could show the other three are incorrect statement, and therefore A is correct. And in fact, atoms are still very small. You can't see with your eye, right? Obviously. So that's the end of this 5-question series. If you found them useful, make sure you click the button on the bottom right to subscribe to the channel. Please share the news about the channel with your friends, your class group chat, your juniors from school, your seniors from school as well, if they haven't found out about the channel yet. And yeah, I'll see you in the next video. Thank you for sharing and thank you for watching.